All right, let's try to evaluate another limit. This one is a little bit more formal in its computation. We've got the limit as x approaches positive infinity of x times the sine of 1 over x, and we're given a let statement which formalizes the problem. A let statement introduces a variable to the problem that is not already present. So that means that we have to have t equaling 1 over x, and again, here's the let statement. Okay, so we're defining a variable t, and this variable t equals 1 over x. Okay, so let's see what happens. Now, if we are going to replace x in our problem with something in terms of t, we have to replace everything. That means we have to replace the constraint on the limit as well. We've got x is approaching positive infinity. Okay, well, we need to know where t is going. So over here in my let statement, if t equals 1 over x, I need to answer this question. As x approaches positive infinity, where is t going? Okay, well, if t equals 1 over x, that is a inverse variation, a rectangular hyperbola that's got a branch in the first quadrant and the third quadrant. Okay, so we've got a rough sketch of 1 over x. So as x goes to positive infinity, the t, which equals 1 over x, that is going to go to 0. So t goes to 0. Okay, so that means then over in our problem, we are going to replace everything that has an x in it with a t. So first off, I'm not going to say the limit as x approaches positive infinity. I'm going to say the limit as t approaches 0. Because as x approaches positive infinity, t approaches 0. Okay, well, I have to replace x with something in terms of t. Okay, well, if t equals 1 over x, x equals 1 over t. Okay, and that's algebra manipulation there. X equals 1 over t. So I've got the limit as t goes to 0, not x anymore. I've got 1 over t. Okay, now I'm taking the sine of 1 over x. But 1 over x, by the let statement, by this definition, that equals t. Which means then now my problem becomes the limit as t approaches 0 of 1 over t times the sine of t. In other words, I have the limit as t goes to 0 of the sine of t over t. And that should look familiar. We've got one of the basic theorems for trig functions and limits, which is the limit as t goes to 0 of the sine of t over t, and we know that equals 1. Okay, so a little bit more formal approach with this limit problem. We had a let statement. If we are going to swap out everything with the variables, we are going to have to swap out our constraint for our limit here as well. So we had to change as x goes to positive infinity to t goes to 0. Once we had that, everything kind of came from our let statement to swap out everything in terms of x from the original problem into terms of t. Once we did that, the let statement makes this problem more simple, and we end up with the answer of 1. Okay.